So this is great. I want to thank everyone for coming. This is the NASA Swarmathon Recruitment Webinar. My name is Paul Secor. I'm one of the Swarmathon coordinators. With me also is Mary Baker.
Hi, everybody. Welcome.
So you might have gotten some emails from either her or myself throughout this time. On the screen with the banner is Mr. Kurt Lloyd, who is a lead software engineer at NASA. And then over in your bottom right-hand corner is Ms. Teresa Martinez, who is the NASA Mura POC and in charge of STEM engagement at Kennedy Space Center. All right, so obviously you're all here for the recruitment webinar. If you'd like to tweet out during the event, that would be super cool. You can tweet out with the hashtag #JoinTheSwarm, or if you're on Facebook, use the hashtag #JoinTheSwarm as well. We're trying to spread the word and really make this to be one of the most prestigious and premier events that NASA has from an education standpoint. So what is the Swarmathon? So we're going to go through in the next 45 minutes and talk all about this. Couple of quick things. I know people always ask me, hey, is there going to be a recording of this webinar? Can I share it with my fellow students or my fellow faculty members? The answer to that is yes. By tomorrow morning, you'll be getting a link. You'll do the same thing. You'll log on and you'll be able to attend and view the recording and watch that. So you can rewatch this if you need to, or you can pass that link on to other people, which will work out great. The other thing is, if you hang around all the way to the end of this, at the conclusion, we're going to put up a nice little link. And that link is going to have a download button that's going to allow you to download the entire PowerPoint presentation that we did today. So you can have that instantaneously at the end. We are not afraid of questions, so if you have questions, feel free to type them in at any time. We're going to do our best to take them real time during the whole session as it occurs. And in addition, we're going to have a Q&A at the end of this. So if we didn't answer your question in detail or you didn't have a chance to ask it, you can save it up. We'll ask it at the end. But again, we're more than willing to entertain questions as you think of them and as you type them in the chat box in that right-hand corner. So with that, I think we'll get started. What is the NASA Swarmathon? Well, it's a technical competition. NASA has found that technical competitions are really a great way to teach, inquiry-based, hands-on learning. And when is it happening? Well, it's actually going to happen here at the NASA Kennedy Space Center, April 18th through the 22nd. That's going to be for our physical competition. As we talk to you about this event, you're going to realize that there's two tracks, essentially, a physical competition and a virtual competition. But the big news is that the physical one is occurring at Kennedy Space Center in April. The good news is if you can raise travel funds, we'd love to have you out here to participate. If you can't, if things are a little bit tight at your university, your community college, don't worry. We're going to actually arrange that you can ship us code, upload code, and we are going to have that code perform at the Kennedy Space Center under your team auspices. So travel is totally optional. And of course, this event is sponsored by NASA, specifically the NASA Minority University Research Education Program. And with us today, we have Teresa Martinez, who's actually the POC for that program and in charge of STEM engagement at NASA Kennedy Space Center. So I guess, Teresa, the big question is, I know a lot of effort's going into this, a lot of money is going into this. Why is it so important for NASA to do a competition like this for minority serving institutions?
Well, these competitions are something fantastic for you to learn hands-on engineering. It's great to hear it in class, but you need some practical application of it. This is the sort of thing that looks fantastic on a resume. It's going to set you apart from the other students who have gone through, and even if their GPA is a little bit higher, your experience is going to be extremely helpful for you on that resume. So we get to reach so many students with these competitions, and you get to learn so much out of it, and then we get something out of it, and you're going to hear all about that from Kurt, so I don't want to steal his thunder. And so this is a win-win for all of us.
Well, that's awesome. We'd like to thank you so much for sponsoring this. None of this would be possible without the funding from NASA. So again, thanks for doing that.
Absolutely. This is going to benefit the students and benefit us. And we're so excited about this.
Awesome. So looking at a little bit more about this, we just did mention it's for minority serving institutions. On our FAQ page of our website, we've got a little link there that can help you determine if you're a minority serving institution or not. But it's open to those schools, and it's open to 4 universities and community colleges. The program we mentioned is funded by NASA, but it's actually the brainchild and operated by the University of New Mexico, where we just saw Dr. Melanie Moses, and she'll be talking to you in a minute. The main focus of the Swarmathon is developing search algorithms for swarming robots. So you're going to see, skills developing in both computer science as well as robotics. And why? Well, the big picture, we're going to have Kurt Lloyd talk to you about this, but he's going to tell you about ISRU, which is in situ resource utilization, which is all about NASA's efforts to live off the land. If we go to the moon, the Mars, an asteroid, or another small body, we need to figure out ways we can utilize the resources there. And that's why these swarmy robots and the Swarmathon is so important. So the big thing, why you want to stick around for this whole webinar, is we're going to tell you about not only how to compete and the benefits and the science behind it, but at the end, we're going to explain to you about how you can get your hands on 3 swarmy robots. Those are about $6,000 in total value. There's also $1,000 available for each faculty member that leads a team at a minority serving institution. And then you're also going to get webinars and instructions like this, as well as other assistance throughout the year. So with that, I'm going to turn it back over to New Mexico and let Dr. Melanie Moses tell you about the science behind the swarmies, which is really intriguing.
So I wanted to give you just a little sort of 3-minute overview of my feelings and my understanding of swarm robotics and how that has led to the Swarmathon. So, before we can send robots to help the folks landing on Mars, we really need to improve the science and improve the engineering. So in the last few years, there have been incredible demonstrations, prototypes, proof of concepts that show that we can have, we now have the technology to build small, inexpensive robots that can swim, can fly, can exist in swarms like those kilobots you see of potentially thousands of robots with emergent behavior, and where they are without any centralized control, communicating with each other to make some pattern, do some small task. The Swarmanoid down there is an example of robots that can attach to each other and disperse, so they can become sort of a single object and then disperse into being multiple objects, for example, to carry lots of small things versus one big thing. And in the middle there, we have our iAnts. Those are iPod-controlled robots that mimic the foraging behaviors of ants. And those are really what inspired us to want to collaborate with NAPSA in this project. And so a lot of these examples that I just showed you and other work in swarm robotics is built on the idea that we can learn from biology, that there are many examples of animals that exist in collectives, schools of fish, flocks of birds, teams of ants doing some cooperative behavior. And we are interested in mimicking the way that those systems are robust. Individual, birds can fly out of the swarm, it still works. They're adaptable to different kinds of natural environments, scalable up to even millions of agents. And we want to emulate this in relatively inexpensive robots that are particularly efficient at tasks that are spatially distributed, meaning, for example, collecting lots of resources from the surface of a planet. And so we can go ahead and, I think, start this video, which shows just one example of our work that's inspired by ants. What we actually did was go out into the desert here in New Mexico, where we have lots and lots of ants, particularly desert seed harvesters. And these ants collect seeds from an environment that probably doesn't look too different from the surface of Mars. It can be pretty sparse out there, and they have to find food. And so what this video is showing, I'm not sure if it's actually going to play, it looks like it's playing now, is simulated ants, a simulation that we built of little agents crawling around on the surface looking for these little dots of food. And those foods items in this case are distributed in different ways. Some of them are scattered at random, some of them are in small piles, some are in very big piles. And what you see the ants doing over time, they will initially collect things from small piles, and then eventually they'll find what they're doing right now, find that big red pile of food and lay what's called a pheromone trail to that pile of food, a chemical scent that attracts other ants to that pile and is reinforced whenever they successfully find food and return as well. And so that's one strategy for foraging. It's very flexible. It works in a lot of different environments. It allows ants to do what they're doing right now, really exploit new resources, but at the same time balance that with exploring for new exploit found resources while still exploring for new resources. So that's one example of, and we can return to the PowerPoint at this point. That's one example of an approach to swarm robotics. What we really want to do is encourage other approaches. And so this next slide will give you just a quick example, let's see if this will advance, there we go, of some work that an undergraduate in our lab has been doing. Lynn Tran has developed a deterministic search algorithm. So in this case, she's designed, just in simulation, a robot that follows this spiral pattern and searches thoroughly. It searches every single square centimeter of the area. When it finds a resource, it collects it and takes it back to some central place. And then it goes back to where it was and continues in its spiral search. So that's a very deterministic algorithm. We know exactly what that robot will do in every case. And it's able to collect resources, those little blue and purple circles out in the world, and bring them back to that central nest. The other, the right-hand side, shows another approach, which is a robot that meanders at random, does what's called a random walk, looks for resources. When it finds them, takes it back to the nest. It might go back to that same location. It might go off and explore somewhere else. It might communicate to another robot. All of these things are probabilistic. And so that's a different approach. And both are effective. And what really interesting is that there may be some arenas, some problem spaces where a really deterministic algorithm is appropriate, others where a probabilistic algorithm is appropriate. And so what we're challenging you to do is try new approaches. We think there are many different ways to tackle this problem of how do I go out onto a surface, find resources I want, and bring them back home. And so this brings me to the actual competition. We are going to challenge you to do this for what sounds like a simple task, which is that teams will win the Swarmathon by collecting the most resources in some fixed period of time, 30 to 60 minutes. And to do this, to compete in this challenge, you'll send your code to NASA. You'll develop it at your school. Some of you with your own swarmy robots, and there are pictures of swarmy robots down there at NASA's parking lot. Your code, you and your swarmies will stay at your school, but your code will be sent to NASA, and NASA will download your code and run it on their own robots to test, to find out who has the algorithm that can collect the most in this fixed period of time. And so I'm going to leave the details about the programming to Josh, who's going to talk about that in just a moment. And I'll go on to the last slide to just let you know some of the benefits to participating as teams. So in particular, we are going to choose 12 teams that will participate in what we call our remote competition. And those 12 teams will submit an application. We'll show you how to do that toward the end. They will be sent 3 of these swarmy robots. As Paul mentioned, they're about $2,000 each in value. Then you will get a programming environment in ROS and Gazebo in order to develop your code and test it in simulation as well as in your real robots. And that's what's going to allow you to compete. And in addition to the competition, we're going to have research opportunities for students. We anticipate 5 of those this first year. We hope to have more in subsequent years, where students can go from one participating Swarmathon school and do a research project with a faculty member in another university. We also want to support the faculty in this. We know we're asking for a pretty big commitment by faculty, and so faculty mentors will get a $1,000 stipend to cheer their team on, to support their team, to make sure their team is progressing through the competition. And then, of course, there are prizes. So prizes up to $5,000 for the winning Swarmathon team. We are going to ask for commitment from schools to, for example, offer a course in their campus where we can engage a lot of students involved in this project, and to do outreach in their community, for example, mentoring a high school team. And so we'll talk a little bit about more of those as we go forward. But at this point, I am going to pass this back to Paul.
So now we have Mr. Kurt Lloyd from NASA. He's a software engineer. He actually works in a really cool place called NASA SwampWorks, of all places. So if you've heard of Skunkworks, it's quite a famous research facility. Kurt's work works in something similar called Skunkworks. So Kurt has actually a swarmy with him, and we'll take it away, Kurt.
Thanks a lot, Paul. As Paul said, I'm a software developer for NASA, and in the last several years, I've gotten really involved in some robotic software projects at NASA. And the SwampWorks group that I support, which Paul mentioned, is really heavily involved in ISRU research. And ISRU stands for In Situ Resource Utilization, and that's just a fancy scientific term for living off the land, meaning don't bring everything you need with you. If it's possible to, extract something from Mars, for example, if you can find ice on Mars, then you could separate the water molecules into hydrogen and oxygen, and then maybe use that for rocket fuel for your return trip home. That's just one simple example of the way you could use ISRU. And the reason NASA's interested in ISRU is it could reduce the launch mass significantly if you don't have to bring everything with you. And that obviously reduces mission cost. And we think if we do it right, we'll be able to reduce mission risk too. So NASA's really interested in ISRU research. And NASA's also excited about swarm technologies. And there's several different reasons why NASA's interested in this sort of technology. When you use swarm technologies or multi-agent systems, multi-robot systems, that system then becomes robust to individual robot failures. So if you spend your whole budget on one really big, really expensive robot and a failure occurs, you might lose your whole mission. But if you spend the same budget on a swarm of robots or a system of multi-robot system, then if there's a problem with one or two of the robots, it's not necessarily going to kill the whole mission. Another reason that swarm technology might be useful for NASA in the future is a swarm of robots has the potential to cover a large area efficiently, which was the focus of the Swarmy project. Swarms are able to find the shortest route to resources, which is going to be useful for ISRU missions when we're out there looking for resources. There's potentially no wasted time if you have a system of robots that is going out collecting resources and then coming back and depositing them at a chemical plant that's going to separate the water into hydrogen and oxygen molecules, for example. If you just have one robot going back and forth and back and forth, there's potentially wasted time there. But if you have several robots that are spaced out in a way that there's no wasted time, there's no time where the processing plant is waiting for a robot to come and deposit. You can always have a constant stream of resources being delivered to your processing plant. And then just generically, there's the synergy aspect of swarming robotics. When you have a multi-agent system or a swarm system, if you do it right, the total sum of the system, the efficiency of the system, or the work that the system can do, turns out to be often higher or more efficient or higher score than the sum of each individual robot. So, for example, in the Swarmy project that I worked on last year for NASA, if one robot in an hour could, go out and find 20 of the barcode tags, you would expect maybe if you put two robots that they're going to find 20. That it would be a linear linear amount of efficiency. But if the robots work together, there's actually synergy there, and the two robots can actually find and collect more robots than the sum of two individual robots. So those are some reasons why NASA is interested in swarming technologies. And NASA is also excited about this competition, as Teresa mentioned earlier. There's potential to advance the current state of the art in swarm robotics, both on the software side and the hardware side. And obviously, as Teresa mentioned, this competition we think will advance STEM education, which could totally benefit NASA's future workforce. So that's a great benefit. Now I'm going to focus on the Swarmy that is on the table in front of me. You can see um, a close-up view on the camera there. This is an early prototype of the Swarmies that we are going to be using in this competition. So you can see the robot consists of a chassis, wheels, a top, and there are computers and sensors in the middle. So let me just remove the top and tell you a little bit about what's inside. So inside the Swarmy, the main component that you're going to see is the computer. This is an Intel NUC computer. It's a PC, and for the Swarmy competition, Josh will tell you about the ROS robotic framework that we're going to be using. That runs ROS runs on Linux, and Josh will tell you more about that. You also can see the Swarmy has a video camera, just a simple USB webcam. We also have 3 ultrasonic sensors in the front of the robot that can be used for obstacle detection. We have, let me turn it around here to the other side. We have a GPS sensor that can tell the robot where it is located. We also have an inertial measurement unit sensor, or IMU. And underneath the main computer, there are a couple other boards that I won't be able to show you on camera, but underneath the main computer is an Arduino compatible microprocessor, and the Arduino is collecting all the data from all the sensors and sending all the sensor data to the PC. The Arduino is also listening for motor commands from the PC and sending those to motor controllers, and those motor controllers are also underneath the main computer there. If I lift off this lid, you can see inside the main chassis. Inside here are 4 motors. Each motor has a motor encoder attached to it, and this will be where the battery sits. So that is a very quick introduction to the Swarmy hardware. And we'll take questions, as Paul said, at the end. So Paul, you want to move on to software now?
Yeah, that sounds good. So let's try to send it back. All right, so we're ready for the University of New Mexico. So if you just want to get, if University of Mexico wants to turn on their audio, that would be great. And then I'll just kill my video once we have audio coming from New Mexico.
I'm here, Paul. Yeah, I'm here, Paul. I'm just waiting on the presentation to load.
Excellent.
There we go.
So we have
Hopefully everybody can hear me okay.
Swarmathon
All right.
development cycle.
So that's right. So we'll stick with the audio for now. This is Josh Hecker here at UNM. Yeah, so I was gonna cover briefly the development cycle that we have laid out for the Swarmathon. So you'll see here in the image, we're going to talk about installation of the software, testing of what you write at your schools, and then most importantly, finally committing the changes to the code as you go. So we'll look here sort of at each of these boxes, first starting with installation. So we're really talking here in particular about a particular flavor of Linux, Ubuntu Linux, and we're going to be really focusing on a particular type of the software, particular version, which is 14.04. And so the first thing to do to get started here is to install a version of ROS. This is the robot operating system. And the version of ROS we're talking about here is called Indigo Igloo. And then once you get that up and running, within several weeks we'll have code available as well. What you want to do is you want to download, extract, and compile the Swarmathon source code on your computer. Once you have that running, really it's time for you and your team to sort of get started and start writing your own algorithm. So this is the part at which you're actually starting with our base code and then adding in the components that you find most interesting, particularly related to things like Melanie was mentioning earlier. So we really want to talk about here, first of all, simulating the experiments in Gazebo. And I'll put a little cursor here. So the idea here is that you're going to be simulating ROS code inside of the Gazebo simulator, which is a ROS simulator that provides highly realistic physics. And you'll also be replicating the experiments here, if your team is selected, in physical robots. So there'll be 3 robots here. This is a snapshot of some of the robots running at Kennedy. And as you're doing those tests, both in simulated and in real robots, you'll be discovering bugs and you'll be adding new features to them as well. So as you're running through that cycle, you'll sort of be updating your code. And finally, committing those changes. So as you're making changes to the code, you're going to be committing the changes to GitHub. So GitHub is essentially the repository where we store all of this code, and it really allows us to maintain strict version control over the code in order to track modifications over time. So as you make changes, you'll be able to see exactly what you've done. And most importantly here, we want to stress that each team will have their own private repository. So all the code will be restricted to your team. It's not something that you'll have to be sharing with everyone. So that's the development cycle. And next we want to look at here the sort of a brief overview of the ROS framework. So you'll see a large flowchart here off on the side. This is what in ROS is called a node graph. And this is just an example of one. When you write your own code, you'll have different looking node graphs. But really what I was trying to do here is encapsulate what happens in ROS to cover robot functionality in both nodes and packages as well. And so you'll see here, I've boxed in red some of the examples of nodes. So we have here a mobility node for driving the robot around. We have here a localization node for the robots to localize in place. And you'll see here that each of these nodes, I've highlighted with these red arrows, each of these nodes is taking an information from the robot itself. So you'll see here, for instance, we have ultrasound sensors here. These are the US center, left, and right. We also have camera images coming in. We have information on GPS, and we have information on the IMU as well. And finally, we can look here at this publish subscribe system. So this is really what ROS is facilitating communication between different C++ programs, different C++ modules in order to actually share information on these different topics. And I don't know if we may have some issues here. I see some comments in the box. So maybe we'll have to send those slides out and have everyone take a look. But in the meantime, we're going to wrap this up, and I'm going to hand it back to Paul. And so Paul can come back in here.
Hey, thank you.
Yeah, no problem. We were also hoping to do the video as well. I'm just realizing.
Yep, let me just do that right now, and I'm gonna let you narrate over the top of it.
No problem. Hopefully the video will play okay here. We'll see if we have issues with the bandwidth. Yeah, so Paul now is queuing up a video. This is a video capture from Gazebo, and so here we have. Go ahead and see if I can get it to play. Here we have 3 simulated swarmies, 3 of the simulated robots that Kurt just showed you. So hopefully everyone can get a look at that. And this is in a simulated environment. You see here, hopefully I can again use the pointer here. No, maybe not. You'll see here at some of these large squares out in space. And really what these are the resources, the actual tags. So you heard Kurt there talking about ISRU and C2 resource utilization. These are the resources that we're attempting to utilize. And see here you see this blue robot. This robot has actually discovered is about to discover a resource out here. It's driving around looking for one, and you'll see it come across a resource as it's searching using its camera. It'll discover the resource, and then you'll see it do a short trip back, essentially returning to a center point, returning to the center of this large grid in order to simulate the collection of the actual resource. So this is the type of environment that you'll be working in as part of the competition. This is a simulated environment, and again, what we're really doing is matching between the simulated robots and the real robots throughout the competition. So with that, I think we'll hand it back to Paul. Thanks.
All right, sounds good. Very cool video. And let's see, let's go now and talk to you about how to get involved in this competition. So we've kind of got the science behind it, why it's important, what the technical challenges are associated with this. But in terms of the deadlines coming up, we've got some that are coming up very quickly. So first of all, we would like to get a intent to apply notice from all of you if you're interested in doing this competition by October 1st. And the reason for that is it's going to help our planning because we've got to scale this event, let NASA know what the footprint of this is going to look like, decide how many arenas we're going to have, all that kind of good stuff. So we want to get an intent to apply. We're looking at the actual full applications due on October 15th. And so you'll need to submit the entire application by that point. NOI is real simple. It's like 4 fields. The actual application has a few essay questions in it, and we'll talk about that in a little bit. But that's due October 15th. Then we plan on notifying everybody if they are selected by November 6th. And so then you'll get notice if you're one of the 12 teams that will be selected. That's what we're currently projecting as 12 teams. And those 12 teams will be shipped Swarmy robots, 3 of them, sometime in January. And at that point, your coursework will begin. And we're expecting everybody that staffs, or I guess starts up a team at their university to also make sure that their students get credit for this activity. And there's 2 reasons for that. Number 1, we find that students are most committed to when it's not only a great project, but there's also school credit available. And the second thing is, it's a lot of work, and the students are going to be very engaged in this whole process. We want to make sure that they get the due credit that they deserve for doing all this work. So we need the university professors to make sure they line up a course in concert with this. So it could be a special topics course, or it could be a full-blown 3-credit course. And then, so within that, that's the physical competition. Now understand, too, there's also a virtual competition that'll occur. In that competition, you don't get any swarmy robots. You just have the ability to program code. That code is then shipped to Kennedy Space Center, where Kennedy Space Center tests it. So the real benefit to the physical competition is you get 3 swarmy robots that are on permanent loan to you while you are participating in the competition. If you don't make the physical competition, there is a spot in the application to opt to be considered for the virtual competition. So you have a number of different choices. 1, you can apply for the physical competition. If you don't get selected, we can see if you get in the virtual one. Or number 2, you can go and you can enter the virtual competition straight out if you just want to go that route. So that's another option. But either way, applications for both the physical and the virtual competition are due October 15th. And so we're very steadfast about that. So you can go to NASA Swarmathon to make that happen, to apply. And now we're trying video, we're doing webcams. So now I'm going to try to share my screen here and give you a little glimpse of the website and where exactly to go to get this. So let me do a new share pod here. Okay. And then Kurt, if you could tell me when you have it up on your screen over there. Okay. So everybody should be seeing the screen right now. We're probably going to have to hold on to questions, or I guess, Kurt, you can help me man questions if we get any of them coming in, if you see any in the chat log, or Teresa, if you see those come in. But so this is the NASA Swarmathon website. We have a lot of information on this. This is jam-packed with details. And so just quickly, I'm not going to make you go through every little click and scroll here, but we did want to show you that there's a lot of good information under Prepare. This is going to basically describe the difference between the physical competition and the virtual competition. And it goes through all the different things that you have to do, the technology associated with it, etc. And so here's a quick example. There's a bookmark right there. We've got information about how it works, the rules, eligibility, the applications, what happens after you get selected, what do you need to do. So all those details are in there. If you want to go in the virtual competition, you just click there. Here's all the details there. It's very similar, but there are some differences. We're going to find that we're going to expect more of the physical teams because you're obviously getting $6,000 of robots. You're getting a $1,000 stipend. And so there's going to be some more activities that you're going to have to do associated with that competition. Also, you can go and get a copy of our draft rules. Understand that these are in draft form right now, subject to lots of edits. We are out at Kennedy Space Center actually measuring parking lots, trying to test out sensors and GPS systems. to make sure that we have the right area, the right number of swarmies performing the right activities. But for now, this is a great way that you can click and get the rules and start taking a look about how this competition is all going to work. So that is a good information to get. Another thing you want to look at is the FAQs. If you have questions throughout this, we're going to try for now to post these questions up on the FAQ site and just keep noticing people that, hey, there's new content posted here. But you can see on this page, you can click onto all the different items and you can get details about, here's, for instance, how do I know if my school is a minority serving institution? There's web links for you there. If my team competes in the physical competition, does it need to travel to Kennedy Space Center? The answer is no. You have either option on that one. So we're going to continuously update this FAQ page. And then most importantly, the biggest thing is the apply page. So I'm going to click that. And if you go there, where we talked about the notice of intent is due on October 1st. Again, that's very helpful to NASA for its planning purposes to understand the scale of this event. And so this is a first-time event. This is actually the first annual Swarmathon. It's going to be offered 2 additional times beyond that at least. And then we're going to be looking at the full applications due on October 15th. And so you can see right here we have a link to both the physical application and the virtual application. They are different. So they're due on the same date of 10/15. But if you want to click into the physical one, I'll go there. The first thing we want you to do is to designate what your MSI type is. And so that will be great. And then you can also, we've got a number of essay questions here. And I know I killed everyone with a scroll, so I'll try not to do too much of that. But we've got some essay questions. We're just looking for approximately 500 words on each of those questions. It could be a little bit less, that's fine. But we want to get some feeling about, has the PI had any experience in managing projects like this? Do they have a plan for assembling their students? And the last question on here is very important to us. We want to know about the number of projected students that you see entering this competition from your university. And a little tip that we'd like to give you is a lot of people, when they talk about computer science, think about this as just maybe a 4 or 5 person project. When in reality, you can actually take a whole computer science class and divide them up into sub-teams, internal teams. Now, you're still only going to get 3 swarmy robots, but there's no reason that those swarmy robots can't rotate around and you can't be doing things sequentially. So you could really get a lot of students involved, and then ultimately you can almost have your own little tournament at your university and move your selected highest scoring team into the finals that competes at Kennedy Space Center. So there's a lot of creative ways, but what we're looking to do, what NASA is looking to do, is reach as many students as possible and make as much of an impact as possible. All right, did I have a question come in? Okay. What will be the size of the arenas? So right now we're planning that. That's kind of in back and forth. Kurt, do we want to talk about that, or should we just hold on that one?
TBD.
Okay, TBD. All right. So let's see. I got another question that came in here. An NOI. This is great. Okay, questions. How much was this program? Okay. So an excuse to play things. Got it. Let's see. Okay, so we'll move on to question B. Well, we need to sync our repo with yours, GitHub, I guess. Guess we're going to be using GitHub, or do we submit final code? So what? Let's take these up. These seem very detailed, so let's take these up at the end of the Q&A. But Jimmy, keep the questions coming. They're totally fine, and other people, feel free to type in as well. So just kind of wrapping up with this application part, you want to make sure you get it in by October 15th. We're looking for you to tell us about the number of students that you're going to involve. And also, if you look at the top of this, and this is my last scroll, I promise, you've got a question here, right here. It says, if you're not selected for the physical competition, would you be interested in doing the virtual competition? And if you click yes there, that's great, because then if for some reason you don't make it, you stand a very, very high chance of getting selected for the virtual competition. And this does not affect your application. I want to repeat, if you select this and say, well, now they're gonna just kind of take me in the virtual competition because I said I'd be willing to do that. Don't worry, that does not get factored into the evaluation. There's a separate rubric for that, and that does not affect the scoring whatsoever. So I think that wraps it up from the website demo. And we stop sharing the screen there. I'm going to minimize that. So at this point, we're going to open it up to questions and answers. And I think I heard New Mexico live on the microphone over out west. So let's go back. First of all, let's get Jimmy.
Yes, so we are here. Sorry.
Okay, sounds good. So I'll try not to step on your
Can
audio.
you hear us?
Yes, indeed.
Okay. Okay, great. So we'll figure this out by the next webinar, I'm sure. So it looked like Jimmy, first of all, I want to say I'm so excited to see 2 teams just signed up. I think that was Northwest Indian College and Morehouse, that already has a team name. That's really exciting. So thanks for these great questions. I'm going to pass this first one on, or this, how much was this program an excuse to play StarCraft? We actually, I don't play StarCraft. We have our own ant simulation, so we but this is a lot of fun. We actually are hoping that people are really going to think of this as a way to be creative and have fun, as well as do some hardcore programming and engineering. There's a question here about GitHub that I'll pass on to Josh.
Sure. Yeah. Let me jump in here, Jimmy. So we're asking about syncing the repos, right? So the general idea is to start with a master. So this is kind of lingo for people who are familiar with Git. We're going to start with a master, which is our code, which is essentially coming out of UNM, which essentially is just a base algorithm in the controllers for the robot, the physical robot, the simulated robot. From then on, it's really up to you, Jimmy, and to the other teams to sort of make your own changes, commit your own changes to that repo. And so what the idea is that we'll have branches. So this is more Git terminology, but essentially other development branches that are coming off of that main branch. And then the idea is that in the future, as we, for instance, maybe find bugs here at UNM, which I'm sure there will be some, that you all at your individual schools can integrate those bugs and sort of merge in with the master from time to time. We'll integrate all that in there, but really the core idea here is to have all of you there making your own changes and committing it through GitHub, and so that we can sort of track changes, keep track of teams that are making changes and what is actually going on there. And then the last question here, I'll see if we have anything additional.
Yeah, I think this last question is, you do understand correctly that the robots in the competition, at least in year 1, only have to find and scan the barcodes. Now retrieval, they don't just have to find them, they have to pretend to simulate taking them back to some center point. So think of this again like Kurt talked about, that you're on Mars and you've got to collect ice. So we want to both locate where that ice is and then simulate the act of carrying it back to some place where it could be used. In future years, we're intending actually to do some more engineering work where things we think will be physically transported. But in this first year, the algorithm to search and retrieve is really what we're after. Oops.
And Jamal asks, what additional resources do we need in our
questions that popped up? Let's see. So the main thing you need is enthusiasm and some code, either some prior coding or willingness to dive into this code base. And we're going to provide a lot of sort of tutorial help and things like that for you. You'll need, if you are chosen as one of these 12 teams, you'll need a space to keep 3 of those swarmy robots. And that's, and then the commitment to do the class in the spring. And so that is sort of a commitment by a faculty member and then participation by students. And that's it. So we're trying to really make this accessible to as many schools as possible.
Definitely a computer. I agree with Paul here.
Actually, good. Okay, so you will need, right, a computer to run ROS as well as a local router, right, in order to facilitate communication between the robots and your computer. A laptop running ROS would be sufficient.
A question came in from Nissan. And Nissan asked, does the robot come with a low-level ROS package for navigation, or do the students have to code it from the ground up?
Yeah, so this is Josh here at UNM. Yeah, we will be having low-level packages for things like navigation, for things like obstacle avoidance, in order to give the students the very basic control over that. And then the students really are going to move on to high-level integration of those. So what do I do when I see an obstacle, or where do I want to navigate and when?
Let's see. Yes, and Deb. So Luis says he has to hit the store for another bottle of enthusiasm. Don't worry, once you get started, it's hard to stop. It's really, it's really fun to work with these swarmies.
All right, Jimmy Acevedo says, to piggyback off my earlier question, what level of competency are you ideally aiming for? Are you more excited about generating interest at all levels, or are you more focused on
Okay,
seeing
yes.
junior
So, right, exactly. So we are excited to involve students at all levels. So we would be thrilled to have, freshmen, first-year students in their first coding class who are participating in this, as well as senior design courses, for example. And part of why we think this will work is there's a lot of open territory here, right? This is not an area where the absolute best answer is already known, and so there's a lot of room to creatively explore new options. So we think that we're going to get good contributions from students at all levels, and we really want to encourage students who are not yet familiar with ROS, who are not yet who have not kind of participated in any kind of coding event of this size before. We want to get you involved. And I can see, and we were expecting this question about Python and ROS. The question is, can we use other languages such as Python or only C++ with ROS? So we understand that there's a lot of interest in using Python. The code base at the moment is in C++. And it would actually be helpful for us if you're interested in working with Python, shoot us an email and we'll discuss with you, see what's going to be possible. The underlying code base is going to be in C++, but that doesn't mean that Python programming won't be possible. So we'll work with schools that are interested in that to see what we can do, and we'll post things up on the FAQ as we navigate through that. Okay, and
All
looks
right,
like we
and
have
you
a
still
couple of other questions coming up, so we'll wait for them.
All right, so everyone can see, we just put up a link for the PowerPoint slides here. So you can click on that and click download, and you'll have all the slides that we covered today. In addition, we'll be sending out a link to the recording of this event, so you'll be able to watch us again or pass that link on. And still, we're here to entertain questions. If you have anything technical, anything about logistics, organizing teams, etc., we're more than willing to answer any questions you might have. All right, so Jamal asks, are we expecting
and
heavy
I can see that
algorithms?
Jamal has a great question. And yeah, sorry, this delay here from UNM is a little problematic. So Jamal has this question about whether we're expecting heavy algorithm understanding from students. And no, we're not. And actually, one way that you could see sort of the range of possibilities is if you go onto the website, one tab that we didn't talk about is the Outreach tab. And that is an example of a really simple workshop that we've run for high school students who have no prior programming experience. They download, this is not in ROS and Gazebo, but in a language called NetLogo. The idea is that they can download this module. It walks you through the process of how do I get a robot or a group of robots to do a random walk, to search randomly, find resources, and return them to a central place. And students are able to get up and running in that very simple environment in about an hour, 2-hour workshop. So there's, you can start there, and the idea is that students are going to get engaged and want and be motivated to sort of grow and start with that baseline and build up. So we're certainly not expecting that students have taken, semesters of algorithm courses, anything like that. Again, introductory classes, classes for freshmen are actually really strongly encouraged. And all right, so let's see. Are we? We'll see if we get a couple more questions coming in. Hopefully, I think Paul showed people how to navigate through the web page to that Outreach tab. And I think we'll stick around for more questions sort of as they come in, and we'll also try to capture the essence of some of these questions on the FAQ.
That sounds good.
I see we have a question. Is ROS operable?
Go ahead, New Mexico.
Okay, so sorry about that. We are really having bad delays. There was a storm. I don't know if we can blame it on that, but so we'll have to fix this IT problem. So the so this question about whether ROS is operable through MATLAB came up, and it is. We actually have colleagues who do that. However, we have not we don't have any intent to sort of integrate with MATLAB. I'm actually sometimes a fan of MATLAB. I do a lot of programming in MATLAB, but we don't intend to use MATLAB packages. And let's see, we will, 2 more questions that came up. One from Justin Chavez. Can the team members be from different colleges? That is an interesting question. I don't think, we haven't thought about that. I don't know if NASA, if the MURET program has an opinion on that. I think we're willing to sort of work with what works best with teams. I would say definitely sort of make clear what your plan is. I don't think we object to it out of the box. Teresa, do you have any input on that?
Yeah, I'd agree with what you said, Melanie. For a team that's receiving swarmies, it's going to be extremely difficult to work together. We love seeing collaboration. Now, if you guys are close enough, physically located close enough that you can work together, that's fantastic, and that kind of collaboration would be awesome. If you're competing virtually and you can work together, again, that's fantastic. So if if there's a reason for that, or if you've got maybe a university that's higher level college wanting to pair up with maybe a community college, that's great. With the virtual, I can see that that working extremely well. And so again, if there's reasons for it and you feel it can work, like Melanie said, not going to say no off the bat.
Great. And one thing that I'll add is that part of our plan here is to, or our desire here is to really foster creativity, and so collaboration is a really good way to do that. And thinking about the long-term goals of this project, right? Sending robots to other planets like Mars, that is a highly cooperative, collaborative effort. And so, the robots themselves are in fact going to be cooperating with each other as you write your own code. And so, while this is a competition, we really want to foster this idea of creativity and collaboration. So keep sending out those creative ideas for working together. And looks like more schools are excited to accept the challenge, so that's really exciting. Jamal had a question here about knowing about their when you're accepted. So oops, am I stepping on your audio?
Nope.
Looks like Paul is typing me a message. In the meantime, I'll just say that that Jamal had a question about when we'll get notified. Yep, and November 6th, he's typing right in there. And Jamal, I know you've talked to me offline, and we can communicate if you have any other questions to follow up. And Paul's also probably answering the question about the presentation, that he's got a link to it there. I will also add, if there are any questions that come up that we haven't answered here, I'm sure over time many questions will come up. So we're encouraging you to send us email at info@nasaswarmathon.com. You can do that just as an email, or use the contact us page on the website. And we will keep on top of those questions. When questions come up repeatedly, we'll make sure we put those on the FAQs. All right, then we have this question about the size limit for the team. We don't have a size limit. That's largely going to be by logistics for your team, right? As Paul suggested, you might have a whole class with 4 or 5 or 6 small teams. You might have a large team where you have older students mentoring younger students, something like that. So, there's not a fixed size limit. And again, we really encourage, sort of creative ways to get lots and lots of students involved. And I see lots of a couple of people signing off and saying goodbye. So certainly, I want to, while we still have a bulk of the people here, thank everybody who was able to participate and listen in and ask questions. It's really great to see this much enthusiasm and these many people, these many teams that are suggesting that they are getting right on it, sending in letters of intent as we speak. So that's exciting to see. And we'll stay around here, I think, for the next couple of minutes in case other questions come up.
That sounds great. So I guess we'll just kind of start to wrap it up on our end in Florida here. Again, as Melanie mentioned, if you have any questions, we have the website. Hopefully that'll have a lot of great information. I just typed in the email address right there in the chat log, so you can click onto that if you'd like to email any questions in. And so we'll be happy to entertain them that way as well. We had a question about the file. It's right there. So if you want to download the PowerPoint, just go to your left, click that, and click the download button, and it'll download right to your hard drive. You just got to know where you're saving it in your hard drive to make sure you can find it again. But hopefully you can manage that. This is a computer science challenge, of course. So this is part of it. Can you find the presentation? And then we'll be emailing out the copy of the entire video of this and everything tomorrow. And that should be a real clean copy because we recorded here. So we've got a real good connection on that. So, Kurt, any final thoughts from the NASA technology standpoint on your end?
My thoughts right now are focused on the attendees of this webcast and the interaction we've had with them. I'm really excited about their excitement and about their questions. So yeah, this is going to be great.
Awesome. And one of the coolest things I think out there is that there's a lot of different educational projects, but this one has real world or outer space implications in that if you go into the NASA technology roadmaps, you will find information about using robots to prospect, and you will find information about swarming robots, and it is being contemplated by NASA. So I would like to think that this competition is not only going to do a great thing in terms of educating students, but this may be the competition that NASA looks back and says, yeah, that Swarmathon really kicked off the whole concept of swarming robots into a new level, and now we're seeing a new technology come out of the agency. And how cool would it be that we all sit here 10, 15 years later and we're watching swarming robots, knowing that the Swarmathon was one of the things responsible for that.
That's really exciting.
Isn't that cool stuff? So Teresa, I didn't mean to steal a thunder. So NASA Education, any final thoughts from you on this project?
I just put it in the chat box that I'm excited to see the questions and the enthusiasm and the NOIs that have already come through as we were doing the presentation. That's so fantastic. This is such a great opportunity for everybody, and go teams, put together, put in an NOI and put in an application.
That's right. And obviously, just want to mention too, you didn't get to meet her. Kathleen Yeppa is in New Mexico. She will be answering questions, as my colleague Mary Baker will too. So there'll be a lot of faces that you'll come in contact as we get more involved in this competition. And we see we got a few more people typing. Excellent. Thank you, Rodrigo. Thank you for coming. Thank you, Gary. Awesome. All right, so I think we're good on this end. I think what we'll probably do at this point is just shut down our windows here, our video broadcast. I will leave the file open for a few more minutes in case you didn't get a chance to download that. We'll give you a chance to do that. And if you want to chat amongst each other and kind of challenge each other and see whose university really has what it takes, I'll leave that on you. We're not responsible for any comments at this point. So you guys can have fun with it. And Melanie, anything you want to say in closing?
All right. So in hopes that you all can actually hear me out there, I'll just jump in and say thanks for participating. We are really excited. excited to have this thing started and have so many people involved at this early stage. We will be in touch, and yeah, we're going to work on those Ethernet issues, and we will. And you'll all get notice about the next webinar. But in the meantime, send us email, check out the webpage, like us on Facebook, all of those things, and we'll be in touch soon.
All right, sounds good. And Tariq, I see you had a question there. We will email out a copy of the presentation as well as with the video link tomorrow if for some reason you can't see that window. So don't fret, we'll make sure we get that to you. So thanks, everybody, and we will talk to you next time on the Swarmathon. Bye, everybody.
Bye.